All right, so as you notice, you have a sub today. However, the day is just a regularly scheduled day. We are done learning new material. So what we're going to be doing is going over our homework, quizzing over that lesson, and then we'll have an activity. It hopefully will help confirm some of the things that we learned. But for right now, we're going to quickly go over the homework. Then you're going to take a quiz. After we go over the homework, we'll pause the video, you'll quiz, and then we'll come back and I'll explain that the activity that you're going to be doing. So we're not going to be able to go over specific questions. I'm just going to kind of make sure you guys are prepared for your quiz. So I'm just going to just say a couple things, and then we'll take the quiz. It shouldn't be tough. I'll make sure you're prepared for every question. So we have to remember what we talked about last class. We have, good sampling techniques and bad sampling techniques. The good were simple random samples. This is the one that is SRS for short. This is taking, randomly selecting people from a population. So every person has an equal chance of being selected. So we remember that it's like taking names out of a hat. Okay, that's the first one. The second one that was good was a stratified random sample. So stratified random sample. This is when we put our population into groups, and then we take a simple random sample from there. So simple random sample is just picking names out of a hat. Stratified random sample, we will group first, then names out of each group hat, which is the simple random sampling of your groups. Okay, so those are good. Some bad ones that we need to remember. Bad were like voluntary sampling. Voluntary sampling was the ones where you would, poll the audience, and the people who raised their hands, they would be the answers. People who would you would poll. Or if you, asked all of your friends on Facebook a question, and then only the people who responded, those are the people you're going to use to your poll. When you do a voluntary sampling, what you end up getting is people who are, very opinionated about a topic, or they like to express their own opinions. You don't get everyone's opinion. So that was a bad one. Another bad one that we need to remember is we have our convenience sampling. And this is when you just get your buddies. Another one, which was one I forgot about, is the judgment sampling, which is when you sample only people who describe themselves as being experts. Experts in quotation marks. You don't know how much of an expert there are. Let's go back to simple random sampling. Now, simple random sampling, if you remember, we can easily do simple random samples using a random digit table. And typically, random digit tables are separated by fives. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then what we'll do is we'll number our, our participants, our population, and we'll assign a number to them. Et cetera, et cetera, et cetera. And we'd say, okay, well, A we'll say is 0.01, B is 0.2, C is 0.3, and so on and so forth. And let's say we had all the way up to, 40 people, 40 letters or something. And we'd say, okay, who are we going to randomly pick from this list of 40 people? Well, we go to our random digit table and we look at 2 digits at a time. So 15, we would say, yes, we will sample person number 15. 68 is out of our range, so we'd skip that. So the next person is 7. 44, skip. 85, skip. 78, skip. 7 again. It's a repeat, so we skip. We get 12. Great. 0 is not in our range. 5 is in our range. Okay, so you all have a question where we will give you a random digit table, and then you will be able to use that random digit table to select. Remember, just to keep going in order, and if the numbers are not in your range, you skip them. It's important to talk about randomness of random digit tables. The important thing about random digit tables is that 0 through 9 can show up, are equally as likely to show up. Which means, and this goes back to the cartoon that you saw, you could have 5 zeros in a row. This is possible. You could have 1,000 zeros in a row. That's possible. Okay? Typically, though, we will have, we won't have this many numbers in a row on our random digit tables. They will, change on us. So digits can be repeated. Things like this are possible. You cannot say on a certain line that certain amounts of numbers will show up. Sometimes if this was our line, we don't have any 5, 6, 7s, and 8s. Okay, any 5, 6, 7, and 8. We just have 1s, 2s, 3s, and 0s. This is totally possible. So hopefully that will help you for a question. If we are looking at, say, a lake, and there's ducks in the lake. Here are the ducks in the lake. And let's say I said, you know what, to sample, I'm just going to look at all of the ducks in this portion of the lake, and that'll be my sample. Well, this would not be considered a simple random sample. It would not be a stratified random sample. A simple random survey would be taking ducks from the entire lake, not in just a portion. So I hope you understand that if we go just a portion, it is not a simple random sample. Okay. That's it. Just remember, simple random sample, you sample the entire population, randomly select anybody, everybody's equally as likely. Stratified random sample, you put them into groups, and then you do a simple random sample of each group. These are bad voluntary convenience judgment. I think I spelled judgment wrong. Judgment. There's no E, judgment. I spelled sampling wrong as well. That's great, sampling. Okay, and that's it. You guys are ready for your quiz right now, so the sub will give you the quiz and pause the video. So go ahead and do that now. I'm going to continue talking and pretend like you've already turned in. Also, you should be turning in. You should have turned in your homework already. So you turned in your homework. You took your quiz. Now we're going to talk about the activity. Okay. This is the random rectangles activity. It's a great activity. We're going to pass out the activity. And what you should have is a sheet of random rectangles here. Okay. And the key is, what is like the average size rectangle that we have? Okay, here's a bunch of rectangles. What is like the average size of the rectangle? On the back, they kind of separated into groups. Don't worry about the back. Let's just look at the front for now. Okay, so the object is to estimate the average size. The mean is the word for average of the rectangles. the size of the rectangle might represent the number of people in city houses, the size of a fire ant mound, whatever. It's just rectangles in this case to just represent something else. Now, it's not practical to examine all 100 rectangles. We will be able to do that actually if we have time at the end. But instead, due to limited amount of time, we only have this class period, we are going to examine a sample size of 5 rectangles, okay? And we're going to start, and you're going to first do a judgment sample, then a simple random sample, and then you'll do a systematic sampling, which is every nth, remember that one, and a stratified. And we'll compare, our averages to those. So you're going to look at this sheet for a couple minutes. And for the judgment sample, you're going to take 5 that you think are, about average size. So let's say I like 66, I like 31, 33, those look good, 37, and I don't know, 72, maybe 72, maybe 76, okay? Those look to be about average size. So it's up to you what you think is average size, but you'll write down those rectangle numbers, 31, 31, 33, 37, 66, 76. I'll write those down. And then I'll record their sizes. So I actually have to count up the sizes of the rectangles. So I go and say this is 1, 2, 3, 4 by 1, 2, 3, 4. So there's 16 total blocks in there. So I will just write down that this is 16 blocks. After I get all of them, I'll just take my calculator and find the average. How do you find the average? You just add up all your numbers and divide by the total. Let's get our calculator out just so that we can make sure we do that. So I will, be able to add, say, 16, 16. I don't know what the other ones are, but just to show you, that's how you can add them up, divide by 5, and let's say my average rectangle size was 13.6. What I would do then is down here, I would say, okay, my judgmental size was 13.6 right here. Okay, don't worry about the shape and the spread. We're just going to do the average size and look at it. Now, we're going to get random. So we're going to do a simple random sampling, systematic sampling. Before continuing, we're going to take our calculators. So everybody should have a calculator. And then what we're going to do is we're going to kind of set up our calculators so that they're all going to be different. Okay, so I'm going to reseed a calculator. So first we do a random 4-digit number. So a random 4-digit number, you guys can do this right now, would be like that. I take that random digit number and I'll press store, which is right here. And then I'll go to math, PRB, rand, enter. And all of a sudden I've just stored a 4-digit number in my random. This will help me make sure that they are different random integers, okay? Now we are going to select 5 randomly selected rectangles from our list using our simple random sample. So that's a simple random sample. Each of them will be equally as likely. To find a random digit, we'll go to math, over to PRB, we will go to rand int, press enter. And what you will do is type in 1 to 100, and then we're going to want 5 of those numbers. So I'll do 1, 100, 5. Enter, and I get 5 digits. If you want to see them all, you can go up and you can kind of scroll right and scroll left. I got 10, 10, 49, 43, 52. That doesn't help me because I got to repeat, so I'm actually going to do this process again. And I'll use these numbers because they're all different. So I'm going to use rectangle 58, 64, 41, 45, and 99. And then I'm going to go look at the rectangles there, count up their sizes, and find the average, okay? Next, we will go into systematic. So we're going to first generate one random number from 1 to 100, record it and its size, and then record every 20th number. So I'm going to find one random digit. Let's say my random digit is 11. Then I would do the 31st, 51st, 71st, and 91st, just like they did. If your random number is 55, you'll do those. Write the random sizes and then calculate the average. Finally, we'll do the stratified. So here we've separated, if you look at the back of your sheet, we've separated all the rectangles into different groups, and there's 20 in each group. What we're going to do is we're going to select 5 of each of those 20. So what we have is extra small, small, medium, large, and extra large. We will select 5. So you got to generate 5 random integers between 1 and 20. And then we will see the average of each of those. So actually, no, we're going to just choose one rectangle from each of them. Sorry, not 5 from each. We will just choose one rectangle from each of the strata. So I generate one random digit. Let's say I have the random digit of 7. Well, if my random digit is 7, I'll use the rectangle number 7 for all of them. And then in my rectangles, I'll go to rectangle number 7, 7, 7, 7, 7, 7, and write down the sizes, and then take an average of all those sizes, okay? We will write down where our distributions are, and then at the end of class, if we have time, we're going to see if we can count up all of the blocks in all of the rectangles and divide it by 100 and see what the average actual size is. The sub can figure out the best way to do this, or if we are working on these individually, you could try to all do it yourselves and compare your answers to your neighbors, okay? And what we will hopefully see is that this is not going to be as good as these 3. And of these 3, maybe one is going to be better than the other, but we know this one is a bad one, and then these are good. But who knows, maybe results will vary. We'll talk about the results next class. You have homework, which is just a vocab worksheet. Make sure you do that. And that's it. Enjoy your long weekend.